Absolute value of negative 2x plus 1 is greater than 1. So we end up doing two equations. Negative 2x plus 1 is greater than 1. And we do another equation. Negative 2x plus 1, now remember to flip your sign again, is less than 1, negative 1. Now, if we think about it, greater than, that means we want all the distances greater than two certain numbers from 0. So if I want greater, if I want my distance to be bigger, we're going to be going this way and we're going to be going this way. So this is going to be an or statement because it's going to be this stuff or this stuff. So subtract 1 to both sides, so negative 2x is greater than 0. And then if we divide by negative 2, we get x is greater than 0. Or subtract 1 to both sides, and we get negative 2x is less than negative 2, so x is greater than, I did something wrong because I thought, oh, well, if I get a 0, nothing's really going to happen. But I made a small mistake. I multiplied by a negative 2, which means this guy needs to be flipped. I need to flip my sign since I'm dividing by a negative on both of these guys. So hopefully that works out. Let's see. So if we want to graph it, we get 0 is going to be open. 1 is going to be open. But we need x to be less than 0. Or x is greater than 1, which is this way, which is exactly what we thought. We knew that it was going to be going, out. So one way we could write in set notation is going to be the set of all x's such that they have two rules. We need x to be less than 0 or x to be greater than 1. And the other way for interval notation is we start all the way to the left, which is going to be negative infinity. Remember, we don't include negative infinity because we can never get to it, and we're going to go to 0. And then we're going to put this union sign, 1 to infinity, which means we're going to go from negative infinity to 0, which is this guy right here, with the union of this guy right here. And that's pretty much what that says.